Good morning, ladies and gentlemen. Just putting together a gearbox. I've been working on this for a couple of days. I haven't been working on it for a couple of days. I've been at it for a couple of days. I've had other jobs to do and things to drop and stuff to do. But it's just about to get its shims worked out, and then I'll put it back together and put the seals in it, and it'll be ready to go back in the bike. So it's not that I'm that slow. I'm not, but that's what happened. Anyway, this shaft is the input shaft. Just to show you what a badly worn box can do and can cost. New front bearing in the front of the gearbox, new 17.5 degree X gear. That's a free running drive gear. It's run by this thrust sleeve here, which I also had to replace. This spring, which forms a cush drive, takes up the shock absorbing a job of on-off throttle movements and rough gear shifts, and smooths that out through the gearbox. It sort of removes the shock load. This is a Kickstarter gear. This bike's equipped with a Kickstarter, and this little bush here, this steel top hat bush, goes on. That's where the bearing sits. There's a seal that goes in the end there, which is where the clutch push rod goes through. And then there's this baffle plate. Now this baffle plate is designed, I believe, to stop oil from getting thrown straight through the end bearing on the input shaft. This is in the back of the gearbox. This is the bearing. It goes on this little top hat. So you push the top hat onto this sleeve, then you push that bearing on. But this baffle plate goes on here. Now, when I was working on this box, when I took it apart, it had some really strange shim values. And one thing that you do learn when you work on these gearboxes a lot is that there is a range of shims that generally they stick within. There are some variations within that range, but the range is reasonably constant. And I found a thrust washer on back to front on the first gear wheel on the output shaft, which had then crushed. You see, all of the shafts as they're machined, they start off as a piece of steel. They get splines cut in them, and the splines get machined away where the free running gears go, and you wind up with a smaller shaft or a smaller diameter. And if they just machine that up to a stop, you would wind up with a right angle corner in the bottom of the cut, and that right angle corner is extremely prone to cracking, stress cracking. So to relieve the stress there and diminish the possibility of that crack going down through the point at the corner of that shaft, it's common practice in fitting and turning to put in a stress relieving cut there, which is actually a groove, a circular, not a groove, but a circular step, a curved step between the larger part of the cut and the smaller part of this cut. That means that there's no sharp corner for any stress activity to happen. And on the first gear, it had been put on backwards. The box has obviously been apart before. It had all steel bearings in it. Fifth gear was falling to bits, whereas the rest of the bearings weren't that bad. But the reason for that was, I believe, that washer compressed when they tried to move it, and it put the end float all the way out. And there were some other things that weren't necessarily done that well. But when I went to put it all back together, so, you know, this is an expensive piece of kit. Like that thing there alone has got a whole bunch of new parts on it. The intermediate shaft's got a new helical drive gear and a new bush in it. The output shaft has got a new bush in first gear because of that falling apart, and we had to get some new thrust washers. I go to put it back together, and I pick this thing up, and this is like a baffle plate. It goes on this sleeve this way, like that, right? And the idea of it is, it's a spacer, number one, but number two, you can see it's got a step in it, and it's designed, I believe, to stop rubbish and metal get thrown into the open bearing. I use seal bearings on these, so it isn't really that much of a deal, but it is meant to be there. When I picked it up, it was squashed flat, completely flat and wonky and twisted, and it had been pushed out with a screwdriver, obviously, to get some clearance off the bearing, and I just don't happen to have another one in stock at the moment. I have had them, I keep them, but I've used them all. So I dressed this one back to the correct shape using 2 sockets and a small bootmaker's brad hammer that I've had since I was a boy. This rounded part is very handy for chasing, and the anvil on the back of my vise. So I've now got it square and flat, and with the recess pressed back the same way. and it fits properly. The recess is there, and this is again why the shims were obviously all poopy, because it's designed to go on that way to step down over that steel bush, the top hat, but it had been put on the other way around. Been put on this way. And then when the bearing came down, the bearing is larger than that surface and pushed it flat, bent these flanges backwards and out. And I don't know how they must be very strong, because I don't know how long it's been in there, but that's what it was doing. Anyway, I've beaten it flat, pushed the recess back in it. It fits, it's nice, it's going to go back together. I hope this shows you something you didn't know before. If you pull one of these gearboxes apart, for heaven's sake, take very careful attention of how it goes. Don't just rely on movies like mine or anybody else's to teach you how to do one of these. They are simple, but they are complex. There is almost nothing in there that you can't put on back to front, and it will cause you grief, trust me. Take care, stay well, till we meet again.